In order to understand the general principles and ideas behind scaling problems, we should start out with reviewing what a power function is. And we'll do this by drawing a function machine. X is the input value going into the power function. And let's remember that the general equation for a power function is y equals a times x to the b. And that's going to give us the y value as the output. So that's the general idea behind a power function. Now let's test out this power function by putting in an input, and this input is going to be x naught. And x naught is going to be our initial value. And this subscript 0 or x naught really just represents what happens at the time when t equals 0. So let's plug this into our power function and we get a times x naught to the b. And then our y value, our output, is going to be y naught. And that's essentially just associated with the initial x value. And so we really just have a point on the original function here, which is going to be x naught, y naught. Okay, so now we've tested that out with the x naught initial value, and we got the output of y naught. But let's say that x subscript 1 is equal to m times x naught. And m can be any number. So if that is the equation, we're going to say that the input is going to be x1, x subscript 1. That's going to go into the power function, and we're going to get y equals a times x1 to the b. And our output is going to relate to the x subscript 1, and it's going to be y subscript 1. So as you can see, we know how x subscript 1 relates to x naught. But a question that we need to ask ourselves is, how does y subscript 1 relate to y naught? So we see the relation here, but how does y subscript 1 relate to y naught? So what we're going to do to answer this question is we're going to plug in m times x naught as our input value. And really, we can do this because this is equal to x subscript 1. So m times x naught is the input. And again, like we've been doing here, the function is going to be a times m x naught to the b. And then our output is going to be, because of the exponential properties, you can distribute this b, so it's going to be a m to the b x naught to the b. And then if we want to better arrange this, so we're just rearranging it here, we're going to get m to the b times a x naught to the b. So here, this number here, where else do we see a x naught to the b? Well, we see it right here. And this is what happens, this value is what happens, and it's what comes out when you plug x naught into the function. So this value is equal to y naught. So there's a direct relationship right here, the same value. And so now we've answered our question about how y naught relates to y1, because now we see the relationship. So if you really look at it, m to the b times y naught is the output. So the basic idea here is that if the input of a power function, y equals a times x to the b, is multiplied by some number m, then the output of that power function is going to be multiplied by some number m to the b. So that's the basic idea behind scaling problems. And we solve this all using the concept of power functions and using the visual aid of a function machine. Thank you for watching.